Let us see about momentum. Momentum, it is the property of a moving object. And the exact definition is the strength or force that something has when it is moving is called momentum. Simple ga cheppali ante the strength or force of a moving body, a moving object. For example, చూడండి అమ్మా, నేను ఇక్కడ కూర్చున్నాను, మూమెంట్ లేదు, ఇప్పుడు జస్ట్ ఇలా కూర్చున్నాను. సపోజ్ లేచి నేను నా ముందుకు వెళ్ళాను అనుకోండి, I will have momentum. So momentum is the product of mass and velocity. Momentum is the product of mass and velocity. So momentum is a vector quantity because velocity has direction. Kada, velocity has direction. So momentum is a vector quantity. So it can be divided into two types. Momentum is of two types: linear momentum and angular momentum. Straight ga veltunnanu nenu, that is linear momentum. Linear momentum is the product of mass and velocity. Linear momentum P, it is denoted by P. Momentum is denoted by P. Linear momentum is defined to be P is equal to mv. Ante entidi? Linear momentum is the product of mass and velocity. Nene unnanu, ala straight ga road meeda veltunnanu, evaro addam nilabaddaru, vallaki taakanu, వాళ్ళు పడిపోయారు అనుకోండి. ఎందుకు వాళ్ళకు ప్రెషర్ ఫోర్స్ తగిలింది అంటే because I have some mass or weight and velocity, that is momentum. If it is in the straight line, that is linear momentum. Okay, next, angular momentum. Angular momentum also called as rotational momentum. That means it is the property of a moving body in circular motion. It is the property of a moving body, moving particle in circular motion, or it is the property of a rotating body. It is also called as rotational momentum. It is denoted by, angular momentum is denoted by L. Okay, angular momentum is denoted by L. It is equal to the product of the moment of inertia and omega. See here, L is equal to I. Moment of I is moment of inertia. Chuddam ento, I is moment of inertia, and this symbol is called omega. Omega means angular velocity. Endukante because the particle is rotating in circular motion, circular direction. Gundrangga tirugutundi. Gundrangga tirugutunnappudu danikuన్న velocity ni manam emantam, linear anam kada, entadi angular velocity. Okay, so angular momentum is the product of moment of inertia and angular velocity. Okay amma, angular momentum deniki untundi? Circular motion lo tirigedanaku untundi. It is the property of a rotating body. It is the property of a particle which is in circular motion. Okay, and it is given by the product of the moment of inertia and angular velocity. Next, let us see what is moment of inertia. If you apply some force to rotate a molecule or to rotate a body, the molecule starts to rotate, but it will resist to rotate at the same time. మీరు ఒక మాలిక్యూల్ ని రొటేట్ చేయాలనుకున్నారు, మనం ఇలా తిప్పగానే తిరగదు. It tries to resist that force. So we have to apply some additional force to rotate the molecule. Adi resist chese nature undi chudandi, danni manamu moment of inertia antam. Every molecule has some moment of inertia. If you apply force to rotate a molecule, the molecule starts to rotate, but it will resist to rotate at the same time. That resistance strength is called moment of inertia. That is denoted by I. Okay, or you can say like this also, simple ga, the amount of force required to rotate a body. Enta force use chesthe a molecule tirugutundo danni emantam, moment of inertia. Okay, next, for example, take a single particle. A single particle is rotating in circular motion. Okay, in case of a single particle, this I, moment of inertia, is equal to the m into r square. M is mass of the particle. Okay, and r is the radius. So the formula for single particle is I is equal to mr square. Okay, if you take two particle, for example, chudandi ikkada, if you take these two particle, m1 is one particle, m2 is one particle, or otherwise you can imagine any molecule H2, for example, H1, H2. You consider these red balls as hydrogens and concept. Okay, mass of hydrogen m1, this m2 is mass of H2 hydrogen. Okay, and here this is the center of the bond. and center of gravity or center of mass is located at this point. This is called center of gravity. Okay, and you imagine these two particles are rotating in this direction. For this kind of two particle case, the momentum is m1 r1 square plus m2 r2 square. Induku here in the case of single particle, it is the product of m into m and r square. Okay, but here we have taken two particles, rendu particles tirugutunnayi circular motion lo, and the r1 is the distance between center of gravity and this particle. R2 is the distance between center of gravity and M2 particle. That is why we are taking this formula. I is equal to M1 R1 square plus this is one particle and this is for one particle. So moment of inertia is equal to M1 R1 square plus M2 R2 square. Okay, next. What is center of gravity or what is center of mass? See, the point at which the distribution of masses is equal in all directions is called center of mass. You just see this figure here. This is the center of balance. Chudandi, the distance between center of balance and this left side boy is 10 feet. Okay, and this right side boy and this center of balance also 10 feet. Right, iddaru kuda equal distance lo kurchunnaru. And one more point, and their weight, ikkada entundi weight inadi 50 pounds, here 50 pounds. They have same weight. Weight same unnaru, equal distance lo kurchunnaru. So the center of balance is located here, middle lo untundi. Okay, center of balance. If you see this case, see this boy weight is 40 pounds and this person 160 pounds. Heavy weight undi ikkada, ee abbayiki heavy weight undi. Okay, and here only 40 pounds. And this is the center of balance. And from this boy to this point is 16 feet distance. Chudandamma, 16 feet distance. And this center of balance to this boy is only 4 feet. Induku ippudu chudandi, center of balance is always located towards more weight. Gurtu pettukondi, ఎక్కువ weight ఉన్న వాళ్ళ పక్కకే కొద్దిగా మూవ్ అయి ఉంటుంది. That is why the distance between this center of balance, center of gravity and this boy is very less. Similarly, if you take this AA diatomic molecule, తీసుకోండి, homodiatomic molecules. For example, you consider this as H2 molecule. Okay, here both are same hydrogen atoms and the electronegativity difference is same. Avuna, imagine that A and A both are hydrogens and they have same electronegativity. There is no shift of bonded electrons. Kadamma, ikkada A ni hydrogen anukondi, ee A ni kuda hydrogen anukondi. They have same electronegativity kada. If they have same electronegativity, the bonded electrons will not move towards this A and this A. Ee bonded electrons are located in the middle, center of the two atoms. Ikkade untayi bond lo unna electrons. Ituvaipu ellavu endukante both are hydrogens. Okay, so the center of mass or center of gravity will be located at the middle of the bond. Ardhamaindi kada ikkada mee point. AA both are same atoms, same weight, same mass untundi, same electronegativity. Rendu hydrogens aithe entidi, they will have same electronegativity kada. If there is no electronegativity difference, why these bonded electrons will move towards this one or this one? No, these bonded electrons will not move. They will be located at the middle of the bond. That is why center of gravity will be located at the middle of the bond for non-polar molecules or diatomic, homodiatomic molecules. Suppose H2, N2, O2, Cl2, bromine molecule ఇలాంటివి తీసుకున్నప్పుడు center of gravity మధ్యలోనే ఉంటుంది. ఎందుకంటే zero electronegativity difference. Okay, the center of mass is located at the middle of the atoms. Next, if you see this polar type molecule, for example HCl, A plus consider as H plus, B minus consider as chloride Cl minus. Okay, hydrogen chloride HCl, just imagine this A plus B minus is HCl. You know which one has high electronegativity in hydrogen and chlorine? Among hydrogen and chlorine, which atom shows high electronegativity?
Chlorine.
In HCl, chlorine has high electronegativity. You imagine this B and this negative partial negative charge like chloride anukunnam. So this bonded electrons A ki B ki madhya undi, H and chlorine ki madhya unna bond undi kadamma. These bonded electrons will move towards chlorine side, B side, because this B atom will have high electronegativity. So they attract bonded electrons. That is why. And also, that is not only because of electronegativity. This B has high mass. Chlorine has more mass or weight than hydrogen kada. So center of gravity shifts towards high mass. Okay, Namma. So polar molecules center of mass shifts towards heavy mass side. Adhamaindi kada ikkada, because B has partial negative charge, here A has partial positive charge. Partial negative charge means high electronegativity. So these bonded electrons will move towards B side. That is why center of mass will be located towards B side. If you take any non-polar molecules, center of mass is located at the middle of the atoms. If you take any polar molecules like hydrogen chloride, hydrogen bromide, or hydrogen cyanide, the center of mass moves towards heavy mass side. Okay, this point clear amma ikkada?
Yes, ma'am.
Okay, next let us see the type of polar and non-polar molecules. You know that polar and non-polar molecules, if there is any electronegativity difference between two atoms in a molecule, the charge separation takes place. Partial positive charge and partial negative charge will develop on these atoms. So such type of molecules are called polar molecules. For example, HCl. Chlorine has high electronegativity than hydrogen. So there is electronegativity difference. If there is any electronegativity difference, this bonded electron will move towards high electronegative atom side. Therefore, partial positive charge and partial negative charge will develop on these atoms. This is the property of dipole moment. What is dipole moment? It is the product of charges and distance. Mu is equal to R into Q. So, polar molecules show dipole moment. ఎందుకంటే dipoles are developed on different atoms kadamma. In polar molecules, electronegativity difference develops the partial positive and partial negative charges on different atoms. Therefore, polar molecules show dipole moment. Okay. So here you can see this. These bonded electrons are moving towards chlorine side. So it is directional. So dipole moment is directional. Dipole moment ki it is a vector quantity. Endukante bonded electrons are moving high electronegative atom side kadamma. Atom electrons electronegative atom side eltunnayi anante dipole moment undi oka direction lo undi ante it is a vector quantity kada. Gurtu pettukoni, dipole moment is a vector quantity. See, it is not only a magnitude, it is a vector quantity because electrons are moving towards electronegative atom. That is why polar molecules show dipole moment. Dipole moment is a vector quantity. That is why we can show like with this symbol. Okay. And next, one important point. Take a polar molecule, same HCl ne తీసుకున్నాం. Take a polar molecule in a plane and consider this molecule is rotating. Hydrogen chlorine ni ila round ga manam steering తిప్పినట్టు తిప్పుతూ ఉంటే position of hydrogen and chlorine atoms are changing. అది అర్థమవుతుంది. But at the same time, electric charge is also rotating. See this electron, bonded electrons movement also changing. So electric field also changing. While rotating the molecules, electric field and dipole moment will change. Because see here, dipole moment direction right side. Here dipole moment direction left side. Actually, this one is wrong. It should be in the downside. And this is right. This is also right. This arrow is wrong. This dipole moment should be downside. Chlorine towards chlorine. Arrow mark should be towards chlorine side. Amma. So here from this figure you can understand dipole moment values. Dipole moment direction is changing. Okay. And electric field is also changing. Electric field ekkada nundi vachindi madam ante bonded electrons are moving towards chloride kada. In this case parallel undi. And here it is moving towards right side. In this case downside, in this case left side, in this case upside. So while rotating, the molecules electric field and dipole moments are changing. So if the molecule is under rotation, it will have some ఎనర్జీ ఆర్ ఫ్రీక్వెన్సీ, అవునా? రొటేషన్ లో ఉంది అని అంటే రొటేషనల్ ఎనర్జీ ఉంటుంది, ఒక పర్టికులర్ ఫ్రీక్వెన్సీ ఉంటుంది ఆ ఎలక్ట్రిక్ ఫీల్డ్ కి. సో ఇన్ సచ్ కండిషన్, ఇఫ్ యూ అప్లై ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్, ద చేంజింగ్ ఎలక్ట్రిక్ ఫీల్డ్ matches with the frequency of electromagnetic radiation. Whenever the frequency of changing electric field matches with the frequency of electromagnetic radiation, the molecule will absorb energy. ఎప్పుడైతే ఈ ఎలక్ట్రిక్ ఫీల్డ్ యొక్క ఫ్రీక్వెన్సీ మీరు అప్లై చేసిన ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ యొక్క ఫ్రీక్వెన్సీకి మ్యాచ్ అవుతుందో, వెంటనే దట్ మాలిక్యూల్ విల్ అబ్సార్బ్ దట్ ఎనర్జీ. Okay, see this. This is the frequency of applied electromagnetic radiation, and this is the frequency of electric field of HCl molecule. So when these two frequencies are equal, when these two are under resonance, this HCl molecule absorbs that electromagnetic radiation, microwave radiation. Okay, and then HCl molecule will jump into high rotational energy level. మెల్లిగా తిరిగేది కాస్త ఏమవుతుంది, కొంచెం స్పీడ్ గా తిరుగుతుంది. So when nu1 is equal to nu2, the molecule absorbs energy and starts to rotate in higher rotational energy level. Higher rotation అంటే ఎక్కడికో వెళ్ళిపోవడం అని కాదు, with high speed అనుకోండి. Okay, this is the principle of microwave spectroscopy. ఈ ఒక్క పాయింట్ మీరు జాగ్రత్తగా అర్థం చేసుకోవాలి. ఓకేనమ్మా, ప్రతి మాలిక్యూల్ తిరుగుతూ ఉంటుంది, దాంట్లో పోలార్ అయితే కనుక బాండెడ్ ఎలక్ట్రాన్స్ మూవ్మెంట్ కూడా ఉంటుంది. ఆ డైరెక్షన్, ఆ మూమెంట్ యొక్క ఫ్రీక్వెన్సీ ఎప్పుడైతే when it matches with the applied electromagnetic radiation frequency, that molecule will absorb that radiation and it promotes to higher rotational energy level. Okay, you know about atom. Electrons rotates in stationary orbits kada, తిరుగుతూ ఉంటాయి. First level, for example, imagine that electron is rotating in the first shell, and this is second orbit. Imagine that electron is rotating in the first orbit. Okay, and I want to send this electron into this second energy level. To promote this electron into second energy level, just example cheptuna, to promote this electron into this second energy level, we have to give some energy, okay, with some frequency. So 5 joules ichanu anukondi. Maybe this energy is not sufficient to promote into second energy level. ఏదో కొంత ఎనర్జీ ఇచ్చారు కదా, నేను సెకండ్ లెవెల్కి వెళ్ళకుండా మధ్యలో ఉందామని అనుకోదు, బికాస్ దీస్ ఆర్ స్టేషనరీ ఆర్బిట్స్. ఎవ్రీథింగ్ ఈజ్ క్వాంటైజ్డ్. సపోజ్ ఈ ఫస్ట్ లెవెల్ కి సెకండ్ లెవెల్ కి మధ్య ఎనర్జీ డిఫరెన్స్ 10 joules ఉందనుకోండి అమ్మా. ఫర్ ఎగ్జాంపుల్, ఇమాజిన్ దేర్ ఇస్ ద 10 joules ఎనర్జీ డిఫరెన్స్ బిట్వీన్ ఫస్ట్ లెవెల్ అండ్ సెకండ్ లెవెల్. ఓకే, నేనేం చేశాను, ఈ ఎలక్ట్రాన్ కి ఐ హావ్ గివెన్ ఓన్లీ 5 joules. వెళ్ళమ్మా సెకండ్ షెల్ కి అని చెప్పాను. వెళ్తుందా ఎలక్ట్రాన్? వెళ్ళి కొంచెం దూరం వెళ్ళి ఆగుతుందా? ఆగదు కదా, ఎందుకంటే దిస్ ఎనర్జీ ఈస్ క్వాంటైజ్డ్. Whenever I supply 10 joules, then only this electron will take the 10 joules and it promotes into second energy level. దానికంటూ ఖచ్చితమైన వాల్యూ ఇస్తేనే అది జంప్ అవుతుంది. So when the frequency of changing electric field matches with the frequency of electromagnetic radiation, then only this hydrogen chloride molecule absorbs that energy and promotes into rotational high energy level. Okay, so rotational energy is quantized. That is why we can say that rotational energy of any molecule is quantized. దానికంటూ కొంత కెపాసిటీ ఉంటుంది, అక్కడే తిరుగుతూ ఉంటుంది. అది డబల్ కావాలి అంటే అంత ఎనర్జీ ఇచ్చినప్పుడే తీసుకుంటుంది సెకండ్ లెవెల్కి వెళ్ళాలి అంటే. ఓకే, సో rotational energy is quantized. We can use this microwave spectroscopy to calculate the bond length and di and poly diatomic molecules. ఎలా అంటే through the measurement of moment of inertia and dipole moment values. So that is why we have studied about moment of inertia. అసలు moment of inertia అంటే ఏంటో తెలుసుకున్నాం. ఓకే, and this spectra is recorded in the gas state. ఫ్రీగా రొటేట్ అవ్వాలి కదా, so that is why this spectra is recorded, will be recorded in the gas state. Moving charged particle develops electric field and magnetic field అని తెలుసు కదమ్మా మీకు. Any moving charged particle develops electric and magnetic field. So here electric field is changing, that is why dipole moment is also changing. So they will have some frequency. If this frequency matches with the electromagnetic radiation frequency, then it catches that radiation and will go to high rotation energy level.